Hello, my friends. Today we are on the week of Module 3. This is the second video for that week. Um, Let me see if there are any questions. So if you have questions, you can place them, general questions, you can place them here under Module 1, which is the area for general questions. So we don't have any new questions. It does look like, well, I wanted to comment on something about Module 2. So there were a couple of submissions that were, among the latest submissions. The deadline was July the 18th, and that was Friday for Module 2. So if you submit at 12:58 p.m., that's before, so before 1 p.m., so that's before the deadline. But if you submit after 1 p.m., then it's a late submission. Just wanted to make sure that that's understood. So this is the hour in Laredo, Texas. This is the time in Laredo, Texas. So if you are taking this course, say from Europe, and there is a 7-hour difference, you have to check what time is in Laredo. You can do that easily by just going to Google and time in Laredo, Texas now, and you're gonna get the time wherever you are. So it has to be 1 p.m. Laredo time. Okay, I also can see that, so for Module 2, I have one late submission, one non-submission, person did not submit, and a couple of wrong submissions. That is, the submissions had a problem with the file uploads. So if you submit and you cannot download the files that you submitted, then you know that there is a problem with the uploading of the files, so you have to upload again. This is why it's a good idea to submit a little bit before the deadline, maybe the day before, so that if you can check a few hours later and make sure that your submission made its way through into the system. I can also see that for Module 3 we already have 5 submissions. Last submission was made 15 hours ago. Yeah, the most recent submissions, they show on top. Okay. Now I wanted to address one topic in the same theme as in my previous video. I wanted to address the topic of sample size. So there are a lot of individuals and companies that use the software to do analysis for other companies. So they are a data analytics professional or a company that does data analytics. And one thing that they have to ascertain is when they do an analysis of a model like this one on the screen, often the question comes up as to whether the sample size is large enough for the analysis. So if I take a look at the results of the analysis, so here I have the results, and if I go to the option View General Results, I can easily see here the sample size that was used, and that is the number of cases or rows in the data. So the number of rows is the sample size, 156. You can also go to data, viewer save raw indicator data. So this is the raw data, non-standardized. And if you look at the number of rows in the data set, that's 156. So that's the sample size. So the question is this sample size of 156 enough for me to analyze this model? And in a prospective analysis, you would answer that question before you do the analysis. In a retrospective sample size analysis, you would answer this question after you do the analysis, right? So after you have the results. And what drives the data analysis size, or the sample size, minimum sample size requirements, is the minimum path coefficient that is significant. Okay, so the minimum absolute path coefficient that is significant, so it can be negative or positive. The minimum absolute value that is statistically significant, in other words, for which the p-value is lower than 0.05, that is the one that drives the minimum required sample size. This is not part of the assignments, but it's something that is important for you to know. So because the graph is a little crowded and the numbers here are not very clearly visible, what I'm going to do is I'm going to go to view path coefficients and p-values, and now I have all of the path coefficients that were there, right, but now in 3 decimals. And as you can see here, the smallest path coefficients are these ones here, like for example these two, they're the smallest, right? But the p-value here at the bottom is not lower than 0.05. The one that is the smallest and has a path p-value that is lower than 0.05 is this one here, 0.183, and the p-value here is lower than 0.01 actually. So is the sample size that I have enough for this analysis? Well, the answer requires me to go, so it's 0.183, so the answer requires me to go to Explorer, Statistical Power, and minimum size requirements, and I will enter 0.183 here, and then I'll click enter, and here's the minimum required sample size using a more conservative method, the inverse square root method, and here's the minimum sample size using a more precise method, 172. So my sample size in my analysis is actually, as I shown before, is actually 156. So the answer here is that it is not. So 156 is not enough for me to analyze this model. So I needed a larger sample size. Now, to address this problem, one thing I could do is go to the results, right, and the offending path coefficient is this one here. It's 0.18 something. So what I can do is tell the client of this analysis that I am not certain about this one because the power of my analysis is not large enough for me to ascertain if this finding that this path coefficient is positive and significant is really correct. So what I can do is then go to the second highest, second lowest. And the second lowest is actually this one here, 0.222. You see, these are non-significant, so they are irrelevant for this. But this one, this is significant because the p-value here is lower than 0.05. In fact, it's lower than 0.01. So let me see if 0.222 is a sample size of 156 is enough for that test. So if I consider that path coefficient my minimum, I would need a sample size in the more conservative method of 126, and I have 156, so that's large enough. So for this model, what I could do is just tell that I cannot be sure that this path coefficient is really significant and positive. Another thing I could do is just remove this link from the model and just analyze the model without this link, and so that would not create any problems for sample size requirements, because when I remove a competing path, the other competing paths tend to go up, so the 0.22 would probably go up a little bit. So this is how you do an assessment of minimum required sample size prior to conducting the after you conduct the analysis. Now, if you want to do it prior to the analysis, you would have to guess what your minimum absolute path coefficient would be based on past analysis, or you could use this default one provided by the software, and the user manual explains why this is the default 0.197, and this gives you a minimum required sample size of 160 using the more conservative method. So if you don't know what your minimum path coefficient will be, you should start with 160. Now if you know, then you can perform this procedure that I just did, using the minimum absolute path coefficient and going up from there. And this is all that I have for today. So today is Wednesday, so there are a couple of days still until the deadline. Deadline is 1 p.m. Friday, Laredo time. So have a good week. Thank you for watching.